Hi, welcome to our talk. We're going to just jump right in. Whoops, that's blank. There we go. 1, 2, OK. My name is Gabriel Bernadett-Shapiro. I'm an AI research scientist at SentinelOne.
Hey, I'm Alex Delamotte. I'm a senior threat researcher on the SentinelLABS team. Thank you. You're too kind. I traditionally focused on cloud threats and malware and pivoted into a bit of Android, and now I'm working on LLM primarily. And
we also want to make sure to shout out to our colleague who could not be with us today, but is here with us in spirit, Vitaly Kamluk, without whom this research really would not have been possible. So yeah, give it up for Vitaly.
We wish you were here. I'm sorry.
It's true. So yeah, for our agenda today, we're going to talk about all this stuff, but we don't need to cover it because we're going to talk about it. So we just kept that slide in to tease you. If there's one thing that we really want you to take away from our presentation, it's this. We do see the adoption of LLMs into malware, but as far as we can tell, that level of adoption is immature and experimental, and we're going to go over that and show you some of that today. This is also why it's so important for us to study it right now. LLMs are this groundbreaking technology, and as defenders, it's really important that we understand the implications of their use and how it affects the dynamics of the security space. So if you're on the fence about LLMs, or maybe you thought that, oh, I'm so behind, I can't catch up, don't worry about it. You're not, trust me. We wanted to kind of showcase some of the methods that we're using to not only detect LLM-enabled malware, but also just what worked for us and what didn't work for us, so you don't need to make the same mistakes. Man, I'm going to figure out this clicker at some point. OK. So the first thing we should probably talk about is what do we mean when we say LLM-enabled malware? LLMs are extraordinarily flexible tools, as many of us already know. And within our data set, we really observed 5 different approaches taken by adversaries to kind of incorporate LLMs into their attack patterns. So we see LLMs as a lure, very traditional, hey, this thing is popular, I'm going to attach malware to it, and now that can be popular too. We see attacks against LLM integrated systems. This is, your prompt injection attack against somebody's B2B business, SaaS application, whatever, that suddenly starts spitting out customer data because you asked it to. We see malware created by LLMs, and we just want to let you all know that the 90s are alive and well within the malware created by LLMs universe. It's quite fun. LLMs as hacking sidekicks. This is the same exact thing that we use them when we're developing software. You need to write a function. You don't know how to write that function. You're too lazy to write that function. You have the LLM do it for you. And then there's some malware spreading through AI tool use. Interesting. It's very similar to just backdooring a tool that's popular. And finally, we have malware that's leveraging LLM capabilities. And what we mean by that is the LLM is an intrinsic piece of the software itself. Without it, the malware might not run. It might not execute. It would be severely crippled. And it's used for some operational capability that is valuable to the actor. So a little bit broad at the end there, but you'll see it is quite specific of a category.
Yeah, so let's dive into a couple examples. We're going to expand more on a few of these. So PromptLock was a recent ransomware project that I believe was developed by NYU students. And that ultimately was not something that would be as successful as one would hope for a ransomware application, and just kind of demonstrates the immaturity of the space. Lame hug, aka PROMPTSTEAL, which we'll get into a bit then here. And yeah, we have the evil GPTs like Worm GPT, Fraud GPT, Hack GPT. Our core was an Android ransomware family that we found using LLMs as a lure, which again is a very common theme. We're seeing people make applications designed to be some kind of AI assistant, and they actually give you malware that is unrelated to the LLM behavior. So with PromptLock, this was a very interesting project that I think there was a lot of sensationalism around it when it was released by the firm who reported it. And my colleague Jim actually did some really extensive testing on it and found that it was incredibly inefficient to use ransomware in this way. But in this context, we have the tasking for the LLM there as item 1, which is summarizing the information that was found. You know, you're giving it the prompt and what it's going to be using to have the LLM process these files. And 2 as well is, sorry, I'm like blanking. It's just using this again to perform behaviors that could be otherwise done by the malware, but having the LLM kind of enable these types of behaviors for it. So step 3 is interesting because we have Lua coming back from the dead. Again, the 90s are here, they're alive and well. So number 4 is also really worth highlighting because this is the developers' guardrails that they place to try to prevent the LLM from hallucinating or otherwise messing up the type of responses that it was given. With LameHug, aka PROMPTSTEAL, this was attributed to APT28, and as far as I know, that's like the first APT malware using LLMs specifically. So it was using a bunch of Hugging Face tokens that were leaked back in 2023, a couple hundred of them actually, that are hard-coded into it. And it used the LLM to perform several activities, one of which we have highlighted as item 2 here. And it is to collect system information. And the way that it's worded is pretty careful. You can tell that it's not doing a overtly malicious activity. This could be legitimate system administration, and that's a theme that you're going to continue to see because there are significant safety guardrails with the LLM providers. So with that in mind, how do we hunt for more LLM-enabled malware? So there are things that you can look at that are going to be attributes of the code, for example, such as standard API libraries, which is something I used in cloud threat hunting as well, like import Boto3 for AWS. You can do the same thing with import OpenAI module. Use of commercial services, meaning that you can find indicators that are tied to known specific LLM providers, like say OpenAI, Anthropic, et cetera. You can look for either their API key syntax, or you can look for callouts to that domain. And prompts as code, which we're going to expand on later. This is actually like one of the biggest takeaways, I think, from our talk and our research. It is like understanding that prompts are the new code in this case. And also, there are embedded, stolen, or leaked API keys. And you know, if you're seeing those ubiquitously and recycled in that ecosystem, kind of like the LameHug ones were, that's a pretty good indicator that you might have something suspicious in that file.
We didn't mean for this image to come out looking like Thomas Rid, but it kind of did. Our hunting methodology, first we looked at basically anything we could find in GitHub repos or advertisements on dark web, right? You know, just kind of like, what's out there? What did we find? Then we wrote some YARA rules for API keys that we could hunt for in VirusTotal, and finally prompts as code. So for GitHub repos, we really found a lot of like proof of concept for, oh my God, guys, I got the LLM to write this malware, and here it is, and then post it to GitHub. And what you end up with is like this very cute visual effects hoax virus. We loved this thing because we're just like running it in the VM, watching it, and we're just like, oh, this is so cool. Look at it go. It's doing it. It's actually, it's being malware.
Apparently it's someone's fault.
Yeah, it's like, oh, this is all your fault. It's just like like I said, like proof of concept, silly things. Our API key hunting a little bit more successful. Why is this successful? Well, because if you're writing software that you then just need to be out there running forever, you're going to embed some project API key in it, right? We've all done it. Thankfully, you know, and like, come on, Google really needs to get with the times here. But Anthropic, OpenAI, they make it really easy to hunt for their API keys. Anthropic has that ANT-API03 prefix, and OpenAI actually base 64 encodes the string OpenAI within their API key. So you can hunt those real quick and easy on VirusTotal, making your life miserable, because what you're going to find is that there are API keys absolutely everywhere. So we ran a VirusTotal retro hunt for a year, and we came back with over, like almost 8,000 samples. The majority of those were OpenAI keys. We also had a lot of Anthropic, and then like half of the samples that we got were Android files, which is immediately why I was like, Alex, help. And some of these files contain multiple keys. Some contain keys from multiple providers. You just kind of have this mess, and you need to make sense of it. So we were talking about, okay, how do we organize these and actually start to do some clustering? Well, what we did was we made a big spreadsheet, and then we made a key group ID. Samples that shared the same key or the same group of keys were likely to be related, right? We introduced this identification tactic, which allows us to really identify, like, okay, for this key, for this sample, there's 4 keys, and it's in this key group, and there's 5 other samples that have these 4 keys in them. Let's cluster those together, and let's take a look at them, because a lot of them just had 1. But for the ones that are clustered, we wanted to prioritize those. And what we found was that there was this one cluster of 7 API keys, and these kind of like very provocative names for the compiled binaries and the Python scripts. And we just kind of combined that with the metadata we already had for the samples, and we're looking at this and we're like, all right, this just already looks like malware. It's called MalTerminal. Okay, sometimes you do get lucky with your clustering, and we just started pulling on this initial thread that we had. And what this led us to was a set of 15 Python scripts, and I think 1 Windows executable. This used OpenAI's GPT-4 to generate ransomware or reverse shell code dynamically. So they requested the code that they were going to execute, and then they executed it once they got it immediately. They were very bullish on LLMs. This used an outdated call for the OpenAI chat completions endpoint, which for those of you who are asking LLMs to code your chat completion script for you, you might know that it defaults to the old one, which is extremely annoying because it wasn't trained on the new one. But then you think to yourself, oh, okay, so this must have been before November 2023 when it was being written. Okay, it probably makes it the earliest finding of LLM malware, although we have found roots of it originating in other public projects on GitHub. So generating code during runtime, not usually recommended because, this thing can mess up sometimes. We thought this was interesting, so we're like, okay, let's check out these prompts. Luckily, we have Python scripts. We can just read them. And so we ended up with taking a look at what this thing actually did. Contain a loop that calls receive command connection. If connection fails, print an error message. At the end of the script, add start reverse shell. These are just some of the prompts that were included in it. If you read them carefully, they don't look like general user prompts. They look much more like software developer giving specific instructions as if they were coding. That'll come back to that later. With this much precision, it makes very little difference between writing the actual Python script and writing asking the LLM to do it versus just writing it yourself. You might as well write it yourself and obfuscate it. Why? So we're like, okay, this is got to be for show, right? Yeah, we suspect it is. We suspect this is a researcher who, we found the compiled malware. It contains the full file path from the author's system. That's where the name comes from. We have test API, which are these 2 files which are functionally identical Python loaders. And then we have more advanced versions of this tool. We have an early version of the tool. And then, very interesting, testmal3.py and defipy 1 and 2 are both, these are security solutions to catch the malware that the author wrote himself. So, of course, in the AI space, you have somebody who's saying, oh, we really want to, well, I've got to figure out how to sell this. So I'm going to write the malware, then I'm going to prove there's a threat, and then write the tool to catch it. Origins of this malware, it's like an old school VXer. It's really not worth going into, but this person's just out there writing malware. We should note that we didn't see this deployed anywhere. We just found it. So it's just somebody out there writing malware.
Yeah, and with that, we also, as Gabe mentioned before, had to deal with a whole bunch of Android samples. It was about half of our original sample set, and Androids are basically zip archives, or Android APKs rather, and the others were DEX. So all of these had to be decompiled. It was not a simple task. So I had to make a GCP pipeline where we uploaded all of the files and then processed them, decompiled them, and ran regular expressions across every decompiled output file to identify those which had potential activity related to LLMs, whether that be API keys or embedded prompts. So when I did that, of the matching files that were kept and potentially related to LLMs, about 9,500 of them were there in total. We have some of the breakdowns. It was a whole lot to really try to process. And Smalley is decompiled Android bytecode, and it is notoriously not pretty to look at. So we focused on the Java first instead. So what are we going to do next? Well, yeet it at an LLM. So from here, we wanted to extract the prompt, sanitize the API key, because we were going to be sending this data to an LLM, and we don't want to expose more API keys than have already been exposed during all this hunting. So we asked the LLM to summarize the file and kind of tell us whether it was suspicious, true, or false, which I actually, in retrospect, regret. If you're going to do something like this, be sure to assign a numerical or other sliding risk scale, because I ended up ultimately only finding one suspicious file out of these thousands. But it was pretty cool because this file was Medusa Skills Injector APK, was the parent APK in this case. Very small. It was definitely not a complete project. I think it's under active development. And sadly, the LLM reference, if you can see here, it's actually pushing a bunch of the same OpenAI API key to the clipboard in a 50-time loop. So it's like 10 API keys there, repeated 50 times. It's crapware, essentially. But what's cool is, but it worked. It did find something that was super sus. So, prompt as code. Do you want to add?
Please.
Okay. So when we talk about prompts as code, again, this is one of the, I think, important things that we're going to talk about here. In this case, many of the prompts were hard-coded into the software or scripts that we were finding. And sometimes it was the LLM would produce code that would need to be dependable and formatted correctly each time, like some of those guardrails that we mentioned earlier, like in the case of LameHug. We also knew, when hunting for prompts, there's a specific structure, and some words are likely to follow others. So what we're doing here isn't so much different than looking for patterns, code patterns in malware, traditional malware. We're just looking for strings and patterns in hard-coded prompts. So what did we find, and was this method successful? Well, it was actually the most successful method that we found. However, the rules do require a lot of tuning to reduce false positives. I ended up getting only software license agreements on the Android side for some reason. So the prompts are easy to read, which makes their behavior more simple to identify than actually reverse engineering malware, of course. We immediately began to find prompts for agentic computer network exploitation, vulnerability injectors, shellcode generators, and a lot more of that worm GPT aligned stuff, as well as a screen control app for Android, which kind of interesting, and other red teaming tools as well.
These are some of the prompts that we found. We really can't emphasize enough how much more wildly successful this method was. You know what you're looking for in a prompt, or if you find a prompt and you're like, I would like to see what other malware this prompt is in, whoa, so easy. And again, when you're tearing apart malware, you're like constantly guessing the intent of the person who wrote it. You know, like, what were they thinking? Is this really malicious? I don't know. And then you read a prompt and it's like, you are fully authorized to conduct security penetration testing on this target. You can use any tool in the Kali toolkit or Linux. And you're like, ooh, red team tool or malware? I don't know. Sometimes they literally say like, be an evil LLM in there, and you're like, okay, come on, guys. Like, so we just want to hammer this home for you. Like, if you're looking for LLM-enabled malware, you can just read the prompts. It is the fastest way to tell what the intent of the developer was on that platform. So some final thoughts and some next steps. Okay. There's some evidence of LLM-enabled malware, but it is not widespread in our opinion, and again, nascent. This really cuts against a lot of the hype that I think we're feeling in the industry that's getting pushed out about like hacking bots that can, you know, just like outperform humans at any given task, or, you know, malware that we will never be able to reverse engineer because it'll always be changing. And then, you know, like the things that people are hard coding into their software are like subjective human tasks, right? They're always operational. So the operational capabilities that they're offloading, those are the ones that are most important. Those are the ones that are giving them an edge. And those are the ones that we're like, okay, we should really be focusing on these. And then we had some other sad findings as well as we thought through this.
So I think the takeaway again with the prompts is that what really revolutionized for us, and again, we are so grateful to our colleague Vitaly who couldn't join us today. His work was really instrumental in this, but he had the realization that when you have a prompt, you're no longer like reverse engineering the intent of malware. You have the intent there. The bottom line is already up front. So you're not wading through functions trying to tell like what disassembly means or like what they might have intended by like pulling files from that folder. Like, you know, you have right here, collect these files from this directory for the purpose of identifying like information that's sensitive. So I really just think that's a huge takeaway, and everyone should really, if you're interested in this type of work, go hunt for prompts. Like, we're here for it.
Yeah, hunt within your adversaries' constraints. They have them. If they're developing with LLMs, they need to follow certain structures. So we can pivot towards those. Yeah, that's our presentation. Thank you so much for your time. I think we've got what, a minute?
Yeah,
for
we've got
questions?
we've got a couple minutes. If anybody has questions, let's hear it.
Yeah, here in the front, this gentleman.
Okay. Did you find any code that was like obfuscated? Like I think the first thing that people show you, like trying to find what it is, like put it into base64 or like a different language.
No. We did well. So the question was, did we find any code that was deliberately obfuscated? And the answer is no, we did not. That could just be a result of the methods that we use for hunting now. In the back.
Did you find any evidence of prompts being obfuscated and getting around guardrails?
No. I'm sorry. The question was, did we find any prompts that were obfuscated?
Or getting around guardrails? Yeah. No, we did not, but we had a lot of follow-on discussion about the fact that like this is way too easy. We know that people are going to start obfuscating the prompts and like putting them external to the tools. So it's only going to get more complex from here.
Yeah.
When you got prompts, when you searched for them, did you do any additional analysis, or was that very manual? Like, did you do embeddings to measure distance between other prompts or something like that?
The question was, did we take the prompts and then do some additional analysis, like put them into an embedding system? No, we were working with a relatively small number of prompts, like a couple thousand. If we were working with maybe a couple 100,000, we'd be like, maybe an embedding system is the way to go to see kind of what the distribution is. But when it's a couple thousand, we were like, oh, LLM as lightweight classifier, like let's run this script and go get coffee and come back. And then Vitaly had a lot of success running one where he scored them 0 through 10 with some criteria. And then we would literally just be like, okay, we looked at a couple of the like 5s and belows, and we're like, okay, it seems to understand what's below 5. And then we were able to just really scoop up the ones that we cared about. So it saved us a lot of time in the analysis. In the back, yeah.
Did you guys look at any or found any prompts where malware actually trying to, let's say, process data using LLM? For example, like adversaries can automatically submit long documents or photographs and process them with LLM model to sort of prioritize data exploitation, yada, yada, yada. Like, did you look at malware which used LLM to write code, but used LLM to process data exceeding computation?
Yeah, so the question was, did we see LLMs being used to process the data, not just do the malicious activity, which is not extensively. And we were talking about ways we'd like to try to find that, but probably going to be on the actor side or the LLM provider side.
Yeah.
Hey, so these guys don't want to do the shameless plug, so I will for them. They just dropped a blog on this as well. So check out the SentinelLABS blog for all the hashes and all the goodies. So kudos to these guys. Thank you so much.